Hello everyone. Today let's solve the problem number 1834, single threaded CPU, right? So what the question states here, we are given a list of tasks. Each task is represented as iterated value of the tasks equals NQ time, comma, processing time. So this one, tasks of I, this one I'm speaking of, right? So here we are given a task, or we are given a list of tasks. Each task is represented as this one, iterated value of the tasks equals this one within the array NQ time, comma, processing time. So we have a single threaded CPU. So this is important. Just listen to this carefully. We have a single threaded CPU. It can process only one task at a time. As we are dealing with a single threaded CPU, it can process only one task at a time. If multiple tasks are available to process, it chooses the one with the shortest processing time. With the shortest processing time, right? So it can process only one task at a time. If multiple tasks are available to process, it chooses the one with the shortest processing time. Again, so if multiple tasks are available to process, then what it will do, it chooses the one with the shortest processing time. So this part is very important, right? So if there is a tie, it picks the one with the smallest index. If there is a tie, it picks the one with smallest index. So they have given all the all the scenarios basically here. First thing is we are going with a single threaded CPU, and it can process only one task at a time. If the multiple tasks are available to process, it will choose the shortest, it will choose the one with the shortest processing time. And if there is a tie, it picks the one with the smallest index, right? So this part is also, I hope this is clear. If the CPU is idle and no task is available, it jumps forward in time. If CPU is idle and no task is available, it jumps forward in time. What it does, it jumps forward in time. Just keep these words on the mind. It jumps forward in time if the CPU is idle and no task is available, right? So we must return the order of processing. What we need to do, we have to return the order of processing by original index of the tasks, by original index of the task. Again, we must return the order of processing by original index of the tasks, by original index of the tasks, right? So I hope the question part is completely clear, man. So you can just go through the constraints as well. You can just go through the constraints as well. So this is the constraints that they have mentioned, right? So the length of the tasks, this one has to be equivalent to n, right? So the value basically, right? So this one less than n, this one also, value they have given here 10 to the power of 5. Same goes with the NQ processing sign. This one has to be less than or equal to 10 to the power of 9, right? NQ, this one NQ time and processing time. So this is fine. Let's move on with the example here. The first example. So I'll do one thing. Let's discuss the approach. So I'll just consider the first example for the approach. Let's directly discuss the approach followed by the complexities, and then let's write the code. So let's discuss the example one. I insist you to try out the same thing for the example two. Example two, right? So let me consider the first example that they have given here, right? So just give me a second, 1 second. Yeah. First example here we have 1 2 2 4. So just give me a second, 1 second, man. Why this is not considering? This is fine. Yeah, here we have 1 2 2 4 3 2 and 4 1. This is fine. This one I'm saying, this one 1 2 2 4 3 2 and 4 1. So the output that we need to get here is 1 2 3 1, 1 2 or 0 2 3 1, right? 0 2 3 1. And this one input we have within the task 1 2 2 4 3 2 and 4 1. This one I'm speaking of, right? So 1 2 2 4 3 2 and 4 1. So the output that we need to get here is 0 2 3 1. Let's see. Let's consider this example itself. So each task is represented as NQ time, comma, processing time accordingly with the question. So in the question we saw this one, right? Within the array NQ and processing time, right? So processing time, I'll just write P, right? P, this is the NQ and this is the processing time within the array. So each task is represented as NQ time, comma, processing time. This one I'm speaking of. This is fine. So what we will do first, we will assign each task to its original index, right? So first one here we have 1 2 2 4 3 2 and 4 1. See here 1 comma 2. So this is fine. This one is 2 comma 4. This is fine. The third one we have here is 3 comma 2, so this is fine as well. And the final one we have here is 4 comma 1, and the final one we have here is 4 comma 1, right? So this is fine. 0, this is fine. 1, this is fine. uh, Index, I'm just writing the index here. This one is 2, and this one is 3, and this one is 3, right? So this is fine, man. 0th index, first index, second index, and third index, right? So here we have 1 2 2 3 I mean 1 2 2 4 3 2 and 4 1, right? So what we have to do here, we have the value 1 comma 2, so we have to enqueue at 1, this one enqueue at 1, and it takes 2 units, and it takes 2 units. This one again, this one we have to enqueue at 2, this takes 4 units. We have to enqueue at 3 at the index 2, this one, this is nothing but the index, and it takes 2 units. We have to enqueue at 4, and this takes 4, this takes 1 unit, this takes 1 unit, right? So accordingly with the this one value they have given, right? So this is fine, man. First part is we will be going with the pre-processing and sorting. Just remember here. So first thing, we will be making use of the priority queue for this particular problem, right? So priority queue, and also we'll be going with the pre-processing and sorting as well, pre-processing and sorting as well. So here 1 2 value we have, that is mapped to the index 1. We have 2 4, that is mapped to the index this one 1. 3 2 we have mapped that one to the index 2, and 4 1 we have mapped to the index 3, right? So here now the sorted tasks will be 1 2 0. The sorted tasks will be 1 2 0 2 4 1 2 4 1. The third one will be 3 double 2. Third one will be 3 double 2. This is fine. And the final one here would be 4 1 3. Final one would be 4 1 3, right? 4 1 3. Basically after sorting, right? So we are pre-processing and sorting here. This is nothing but the task 0, this is nothing but the task 1, this is nothing but the task 2, and this is nothing but the task 3, this is nothing but the task 3, right? So task 0 followed by task 1 followed by task 2 followed by task 3. So this is after sorting 1 2 0 2 4 1 3 2 2, and this one 4 1 2. So we are just going with a, we have mapped this one to the particular index, right? So the values we have mapped with a particular indexing, and this one's zero based indexing, it starts with a 0, right? So that is how we got here 1 2 0 2 4 1 3 2 2 and 4 1 3 4 1 3, right? So now this is task 0, the first one, task 0, task 1, task 2, and task 3, right? So next we have to go with the simulation, right? So now basically simulation begins here, right? So we have to simulate the CPU processing using the minimum heap. So as I've said, we will be going with the min heap or the min priority queue. So we will be making use of the min priority queue or the minimum heap. As I've said, we'll be going with the min priority queue or the minimum heap. So we simulate the CPU processing using minimum heap, that is based on lowest processing time. If it is tie, then we will be going with the lowest original index, right? So this they have given in the question itself. So we have to maintain time, nothing but the current CPU time, I, nothing but the pointer over sorted tasks, PQ, nothing but the priority queue, and the result, because we have to go with the result array of the particular order, right? So that is the reason we'll be going with this for. So just remember this thing first. We have to simulate the CPU processing using the minimum heap. So we will be going with the minimum heap or the minimum priority queue on lowest processing time. And if it is tie, then we'll be going with the lowest original index. These two things are very important, man. Again, I'm gonna read out this loud. Just listen to this. We simulate the CPU processing using minimum priority queue based on what? Based on lowest processing time, and also if it is tie, then we'll be going with the lowest original index, right? So let's go with the step by step execution. Now let's see the step by step execution. So let me delete this one. Until here everything is clear, I think, man. We have just mapped this one to the index, and we are considering this one as task 0, task 1, task 2, and task 3. So this one will be 1 2 0. As we are going with the 0th index, this one will be second index, so this one will be first, and this one will be second, this one will be third, and this one will be fourth, right? So this one 1 2 0 2 4 1 3 2 yeah 3 2 2 and 4 1 3, right? So let me delete this one. Until here I hope everything is clear, man. Let's go with when time is 0. when time is 0, right? So first initially we have to go with when time is 0, right? When time is 0, we have no task that we have no task when time is 0, right? So NQ time has to be greater than or equal to 1. Every time NQ time has to be greater than or equal to 1. So at time equals 0, we do not have any task, and so we have to jump to time 1. We have to jump to time 1, nothing but NQ time of task 0, NQ time of task 0, right? So let's go with that when time is 1. So when time equals 1, right? So when time equals 1, so what we have to do here, we will go with the task 0 that is available, nothing but NQ time equals 1. So here when time equals 1 t, whatever I have mentioned, NQ time, so this one I'll just write, I can just write ET here. This one NQ time will be 1, right? So time is 1, NQ task 0 is available now. So NQ time is 1. We have to add this one to the priority queue. We have to add this one to the priority queue, nothing but we are adding the first task, nothing but the task 0, which consists of 1 2 along with the index 0, right? So this one, first one, so this one is nothing but task 0. We will be adding task 0. So here we have picked the task 0, nothing but processing time becomes 2. Processing time becomes 2 here, right? So processing time becomes 2 because we have come from t equals 0 to t equals 1. This is processing time is 2, right? Not processing time is not 1 now. Processing time is 2 here. So we have to process from time 1 to 3. Basically result will be 0 itself, right? So now next let's go with the time equals 3. Next let's go with the time equals 3. We saw for time equals 0 1. Next we will go with the time 3 basically, right? Next we'll go with the time 3. So during this time, tasks 1 at 2 and 2 at 3 are available. Tasks 1 at 2 and 2 at 3 are available. So we have to add both to the priority queue, nothing but we have to add task 1. So this is we have to go with this one, task 2, nothing but as it is 0 indexed, we had went with the task 0, task 1, task 2, task 3, right? So this we are considering this one as first one, don't get confused here. So this will be we will be adding first task 1 and task 2 basically. So accordingly with the 1, if we start from 1, we have to go with task 2 and task 3, right? Task 2 and task 3 means we have to add 2 for 1 and 3 to 2 to the priority queue. 2 for 1 and 3 to 2 to the priority queue. So here when time equals 3, when time equals 3, what we need to add here, this one, task 1, task 1, nothing but here, nothing but uh, 2 for 1, 2 for 1, we have added 2 for 1 to the priority queue. And when task 2, we are adding what we are adding, this one, 3 to 2 to the 3 to 2 to the priority queue, this one, 3 double 2 to the priority queue, this one and this one, this is fine. So now priority queue equals task 2 comma task 1. Basically task 2 has the lower processing time, so we are picking the task 2, nothing but which takes 2 units, right? So process time will be from 3 to 5, from 3 to 5, result will be 0 comma 2 basically, from result will be 0 comma 2, right? So I hope this part is clear, man. Now we have to go with the 5. After time equals 3, we have to finally not finally, basically we have to go with the 5. For 5, what we will be doing, this one, when t equals 5, we have considered for t equals 0, t equals 1, t equals 3. Now we are going with t equals 5. So here task 3 is now available. Task 3 is now available at this one, at uh, at 4 basically, at 4, right? So as we are going with the zero based indexing, we will be adding this one to the priority queue. Means task 1 and task 3 are in priority queue now. Task 1 and task 3 are in priority queue. So task 3 nothing but 413. Task 3 nothing but 413 has the smallest processing time. Task 3 nothing but this one I'm speaking of, 413. Task 3 means this one, right? We went with task 0, task 1, task 2 and task 3 mainly, right? So we started with this one. So task 3 we are considering only task 3. So task 3 413 has the smallest processing time, so we will pick the task 3 and take 1 unit. We will pick the task 3 and we will be taking 1 unit, right? So we'll be taking 1 unit. So we will process from time 5 to 6. We will process from time 5 to 6 within the this one when time equals 5, right? So result will be 0 2 3. Now in the previous step we had 0 0 2 0 2, right? So in the time 3 uh, in time 0 we didn't get anything. In the time 1 we got this one, what do we call, um, result equals 0, right? In the time 2, where did I consider this one? Time 1 is fine, time 2 is not there, time 3 we have considered, right? For the time 3, the result we got here is this one, 0 comma 2, 0 comma 2. For the time 5 we have got 0 comma 2 comma this one, when time is 5 we got 0 comma 2 comma 3, right? So finally we will go with when time equals 6, when time equals 6 basically, right? So when time is 6, when time is 6, only one task is left in the priority queue, right? So only one task is left in the priority queue. So we have to pick the task one that takes 4 units. We have to pick the task one that takes 4 units, right? So only one task is left in the priority queue when time is 6, as we are considering the this one minimum priority queue, right? So only one task is left in the priority queue, so we have to pick the task one that takes 4 units, nothing but it processes from time 6 to 10. For this one it processes from time 6 to 10. So we have only one task left in the priority queue, we are picking that task itself and it takes 4 units. Now we are processing from time 6 to 10, and the result we have only one this one, right? So this one will be only one task left, right? So this one will be 0 comma 2 comma 3 comma 1, 0 comma 2 comma 3 comma 1, right? So now we have the output 0231, 0231, which is equivalent to the output that they have given for the example 1 within the question, right? So whatever the output that we got is equivalent to the output that they have shown for the example 1. The same thing they have explained here as well, same thing they have explained here, but they have not mentioned the this one, what do we call, data structures and other stuff. We have discussed this one related to the code as well, right? So along with the uh, this one data structures that we are making use of and other stuff, also the calculation part we have discussed, right? All the things we have discussed within the approach. So this is how we got the result 0231, right? So let me delete this one. I hope this part is completely clear. We got the output 0231, which is equivalent to the output that they have given for the example 1 within the question. As we are completely familiar with the approach, now we can discuss the time and space complexities. Basically, we can discuss the complexities part, right? So now we can discuss the complexities part, right? So just give me a second here. Just give me a second here. Hmm. So what will be the this one basically complexities? Just give me a second, 1 second. So see, when we discuss the approach, the first step itself was to sort, right? Sorting, right? Sorting, and we mapped that one to the particular index. First step was sorting. So for this one, we don't have to go with the sorting, but for other test cases, we have to go with the sorting, right? And then we have to map that one to the particular index. So we went with the sorting. So sorting the tasks by NQ time. That's what we did. That will take big of n log n. That will take the time complexity would be big of n log n in simple terms, right? So sorting the tasks by NQ time will take big of n log n into logarithmic n time complexity, right? So this is fine. So each task is added to the priority queue once and it is removed once. Each task is added to the priority queue once and it is removed once, right? So this we know from the approach, right? So for n tasks, each operation is logarithmic n times, nothing but total it will be big of this one itself, big of n log n itself, right? So overall, it will be big of n log n plus big of n log n. That will lead to big of n log n itself. So overall time complexity would be big of n into log n. So what will be the space complexity then? Space complexity would be big of n, because we will be going with a extended keyword. So basically just remember this one, we'll be going with a result array, as I've showed a result, right? Res or result or answer array, anything you can go. We have to maintain another array just to store the results basically, and we will be going with the priority queue pq at most n tasks in it. with at most n tasks in it. We'll be going with the priority queue, we'll be going with the result array as well, and also auxiliary space that we'll be making use of here as would be big of n in total, right? So also we'll be going with the extended keyword that you'll come to know when we write the code. Basically, what does the this one extended this one keyword does here means it stores the tasks with the original index, nothing but which is of size n, which is of size n. Basically extended keyword, priority queue, as well as the resulting array. So the auxiliary space would lead to big of n in total. So the space complexity would lead to big of n. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and big of n respectively, big of n log n and big of n respectively. So let me delete this one. Now we are completely familiar with the approach and the complexities. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. We are good to write the code. Let's start writing the code. Right. So within the this one, what do we call, within the get order this one method. So first we'll be making use of the length of the tasks everywhere, right? So I'll just go with int n equal n equal tasks dot length. So this is fine, and also we'll be going with the enqueue time, processing time, as well as the original index. So this will be int mm, extended equals new, this one will be int n3. So this is fine. Let's go with the iteration part. So this one would be for int I equals 0, I less than n. So this one will be I plus plus. So this is fine. Within the for loop, what we'll do, as I've said, we'll be going with the extended array, right? So this one, extended array, this one. So now let's make use of the same thing. Let me copy this one. I don't want to type this one again and again, man. So this one will be extended. First, we are going with the extended array with enqueue time, processing time, and original index. Nothing but three times we have to consider, right? So let me do one thing. First time, let me write it, and so for the second and third time, I'll just copy paste the same thing and make the necessary changes. So this one will be I0, task I0, right? So this one, let me copy this one. Let me paste it over here again. So let me paste it over here again. So this one would be I0, this one would be I1, and the final one would be I2, right? So this one will be um, I, and this one would be uh, tasks of this one remains tasks of I11. So this one will be tasks of I1. This is fine. So the next step would be we have to sort by enqueue time. We have to sort by enqueue time, right? So based on the approach that we discussed, we have to sort by enqueue time. So I'll just go with the first step itself was to sort, right? So I'll just go with arrays dot sort. So again, this one, let me go with the extended keyword here. Let me copy this one and paste it over here. So we are sorting based on the extended time, I mean enqueue time, right? Sorry, this one will be a comma b, and this one will lead to integer dot compare. So this one will be a of 0 comma p of 0. So this is fine. I hope this part is clear, man. So next what we will be doing, so we will be going with the minimum heap or the minimum priority queue. So basically we have to sort by processing time and then index, right? So I'll just go with the priority queue. As I've said, we'll be going with the minimum priority queue, right? So we'll be making use of the minimum priority queue. Let me give here priority queue. So this is fine. Int, uh, this one will be, let me consider pq equals new. So again, we're creating the instance of priority queue, right? So here let me give priority queue here. This is fine. uh Again, so I'll just give a comma b here. So this is Java, this one lambda expression, right? So this is fine. Just give me a second here. I'll just go with a of 1 if it is not equal to b of 1. uh this one will be integer dot compare. So this is fine. A of 1 comma B of 1. This is also fine. uh, this will be if it is not equal to A of 1 is not equal to this one B of 1, then we are comparing this one, right? So we are just sorting this one based on the processing time. What if it is equal to A of 1 as this one, equivalent to the B of 1? Then we have to compare A of 2 and B of 2, right? So for that one, let me copy the same thing and make the necessary changes. So here I'll go with this one instead of A of 1. So we have to display A of 2 comma B of 2. So this is fine. So this is it for the sorting, basically based on the minimum heap. So in we have considered the minimum heap here, nothing but minimum priority queue. So what we are doing with the priority queue here, minimum priority queue, so we are sorting by processing time and then by index, right? So I hope this part is completely clear, man. Next, let's move on with the further things. Let me initialize time to 0, time to 0, I to 0, and also index to 0. This is fine. Also, let me go with the result. This one new int of n, new int of n. So this is fine. Yeah, this is fine. So uh, let's do one thing. Mm, so we have to enqueue all the tasks that are available up to the current time, right? So how can I write that one? Instead of the for loop, let's make use of the while loop, man. I hope this works. Let's see. All we have to do is enqueue all the tasks that are available, right? So I can just write here I less than n, or this one, not of priority queue. So priority queue shouldn't be empty, right? So that one also we have to consider. PQ dot is empty. So this is fine. So within the while loop, what we'll do, we have to enqueue all the tasks that are available. Again, let's consider one more while loop. Let's see whether this works. So when I less than n, and let's go with the extended keyword here. Let me copy this one, paste it over here. This one has to be I0, first task, basically task 0. If it is less than or equal to time, then uh, let's make use of the offer operation that is provided by the queue, right? So priority queue, basically. So variable name we have considered PQ, right? So I'll just go with offer. So this one will be extended of I, extended of I. So this is fine. Let me increment the I. Let me increment the I. So this is fine. Let's move on with the if condition. So here, if out of PQ is empty, so priority queue, if it is not empty, then what we need to do? So this one, I'll just consider the current. So as I have said, we have to enqueue all the tasks that we have done. uh, we have to enqueue all the tasks that are available and up to the current time we have to do, right? So up to the current time means, again, the priority queue should not be empty. So let's consider current time now. So this one will be, I'll just go with the current. So we have to enqueue. So let me make use of the poll operation that is provided by the priority queue. So this is fine. Let me go with time equals time plus current of 1. This is also fine. And finally, we have considered the variable result, I think, right? So yeah, here we have considered variable result. This is fine. This one will be idx index plus plus. So this will be uh, equals current of 2. This is also fine. Uh, Else what we will be doing, if no tasks are available, then we have to move the time to next available tasks. Means I'll just assign time to extended. So this one will be extended extended I 0. This is fine. Extend I0. So this one, let me come out of this one entirely. So finally, let me return the result. Let me return the result, right? So this is it for the code. Let me format the code once. Let me hit the run button. So I hope this works for all the test cases, man. Let's see. Yeah, you can clearly see here the sample test cases are getting passed here. So let me hit the submit button. So let's see whether this works for all the test cases or not. So yeah, uh, this works for all the test cases, right? So the code works for all the test cases, right? So this is fine. Now I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.